So guys, the next chapter we are starting, it is graphs. Okay, very important, though very basic. Just you need to understand things. Graphs. I hope you know things. Like uh, you have to know the basics of the graph. I'm just looking if there is any tool actually to help me with the graph, but I don't think so. Okay, so graph. Say for example, if I'm doing the graph of xt, displacement versus time. So you are aware about the slope of graph. If not, I'll just give you an idea. Slope is just like, if I'm talking tan theta, or at any point, this is some graph. If I'm talking about the slope, is the slope of the tangent at that point, or we can know by differentiating at that point. And the integration, which is brought by which can be, the slope can be determined by the differentiation. Okay, or it's actually tan theta of the angle which the tangents makes. Or if I'm talking about the area actually, which is brought by which can be find out or determined by the integration. And area is can be determined by the integration of that. Say for example, this y dx, this was y, this was x, and this small width is dx. So I'm just giving a quick revision. We had done that in mathematics, basic mathematics as well. Okay, so displacement versus time. If I know the slope would give you, that means dx by dt would give you velocity actually, and area would give you nothing. Okay, if I'm talking about vt, for vt curve, the slope would give you that means dv by dt, it would give you acceleration, and area, that means integration v dt, that gives you displacement, s, displacement. Okay, and for at curve, acceleration time, the slope would give you dA by dt. So many would say nothing, but it is a thing. It is a physical quantity called jerk. And area would give you, that means A dt, area would give you velocity, V, velocity. Okay, so these are some basics of these things. Let's try to figure out the situations, then I'll give you more things about that. Okay, first of all, for this equation of motion, v is equivalent to u plus at, and we can use equation of motion only when the acceleration is constant. So this is constant. So how do you think the graph of v, velocity and time b? It would always be a straight line. It would always be a straight line. The graph of v and t would always be a straight line, v versus t. And if I say what is the graph of a and t, because the acceleration is always a constant, it is a constant, so the acceleration is constant, so the graph of a and t would always be like a line parallel to the t. And the graph of x versus t, displacement versus time, if I'm talking of displacement versus time, so that graph, to find out that graph, you see s displacement is ut plus half at square. Can you see the relation between the s and the t? It's a quadratic. So the graph of displacement versus time is a quadratic one, and it depends on, you know, A. If A is positive or if A is negative. If A is positive, so it would be a, you know, parabola. See, it would be a parabola in all cases, because the thing is, it is a quadratic relation. So it can be like this or it can be like this. That depends on the value of A. Okay, but it would be a parabola. Okay, so I just need to check something. Okay, then no problem. So let's I give you a graph and let's ask you something, whether you can actually comprehend the graph or not. So this one is x versus t graph, and the graph is like this. Okay, t2, and this one is t1. So if I ask you, can you actually know, you know, about the motion of this uh, body particle, where it is, you know, turning back, where it is, you know, what is the velocity at various point, what is the displacement at various point, can you actually comment over it? So what is my question? Can you see that the velocity, the slope at this point is 0? Yeah, that is 0. That means velocity is 0. That means turning back, it's a point where it is turning back. And do you know there is a quadratic, this is a parabolic graph, so acceleration is constant. So what would be the nature of the velocity time graph? It is a straight line. First of all, it starts with some displacement x naught. Origin we took as 0 displacement. Okay. So take for example, it starts from this particular position. Origin is a reference, and it goes like somewhere, and at time equivalent to t1, it turns back, and then again comes, and at time t2 displacement is 0. So displacement reference we are taking as origin. So this is the t2 time. Okay. So if I need to draw v versus t, so can you see that the velocity is decreasing, and then it is going in other direction, and it's going and going and going. And we know that the velocity and time graph would always be a straight line. So I'm just drawing it. So it starts from some velocity, and then velocity becomes 0, and then it decreases, but in the other direction, negative direction. This is t1, and there's somewhere it would be t2. Okay. And what would be the acceleration and versus time graph here? The velocity is increasing, so acceleration is like negative always. Can you see that? Velocity, it is increasing, but in the opposite direction. Huh? So the acceleration versus time, where the velocity is decreasing as well, firstly, and then increasing in the opposite direction. So A versus T would be like this. Okay. Okay. So these were the different problems I've shared with you, situations I've shared with you. I'll ask you another one, and better would I give you data and all, and then we'll ask everything about it. Okay, I'll give you data as well in this situation, and would ask you everything. So you can start like this. This is the xt curve. Start from somewhere, and like this and like this. So let's see where does it goes. This point is like 5 seconds. T equivalent to 5 seconds. Okay. It starts with 10 meter. Okay, so acceleration I also give you, like acceleration. See, if I give you acceleration is 2 meter per second square is the acceleration. Can I know the value of this displacement? Yeah, easily. V square u square plus 2as. Acceleration is positive or negative? Take acceleration as negative. Okay, so what would be the s? 0. Velocity at this point is 0. Okay, v is u is 10 meter 10 square. U is also 10 meter per second, and acceleration is -2 into s. So thereby I can know the value of displacement, and that would be 25. So 25 meter is this, so this will be actually 35 meter. So this will be 35 meter. Or I can ask you this with a diagram as well, and ask you to plot various curves. Say for example, I give you this data. Okay, that this is 10 meter, and the body starts from here with a velocity of 10 meter per second, and acceleration is there, and which is 2 meter per second square. So you can know that the body would go like this and then turn back, and then this. So this time is being given as say for example, I ask you everything, find this time. Okay, find even xt curve along with the markings. Find xt curve, find vt curve, find at curve. These all things if I ask you. So this is the PhD over this. Everything I have given you, I am asking from you. So this time would be 5 seconds. You can easily know that the velocity is 2, acceleration is velocity is 10, acceleration is 2, so it has to become 0 with a rate of 2. So time would be 5 seconds. And this distance I have already found. This would be 25, so that would be 35. So what would be the displacement? And acceleration is constant, so displacement versus time would be, and it is negative as well, and so it would be a displacement versus time would be a parabola, and a parabola downwards. So it would be like this, or I had drawn it previously as well. So this would be 10, this would be 10 where it started, this would be 35, origin is the reference, and this time is correspond to 5 seconds, and you can find easily this time as well. This is the time when it is coming to back to its origin. The displacement is becoming 0, so you can find that time. Okay, so what is the velocity time curve? What is the initial velocity? 10 meter per second. Okay, when does the velocity become 0? 5 seconds later. So velocity time is easiest curve. Okay, it would be the easiest curve over here for the same solution. If I need to find VT curve, so that would be this only. This is 10. This was 10 meter per second. This is getting 0 after 5 seconds. And can you look at it and find acceleration? Acceleration is 2, -2. Can you see that? The slope of this. So AT is simply AT curve is AT curve is this one, where acceleration is -2. Okay. VT is this. So this slope is 2 na, tan theta. Okay then.